let's talk about how to find the standard error for the difference between two proportions. First, let's talk in general about what a standard deviation of a difference means. So just like for standard values, or single values, we need a standard error as a ruler to measure how different our observed is from our expected. But now that we have two variables, this gets a little bit more complicated. Specifically, we want to know how we find this standard error. Well, let's think back to the probability section and what we did with random variables. All we're doing here is the same as this equation here. We are taking the difference, which is x minus y, so our expected value is expected value of x plus or minus, in this case minus the expected value of y. For the variance, we could just add these. However, remember we had to use the Pythagorean theorem of statistics in order to find the standard deviation of the difference. So we take the square root, and we can go from there. Now, the standard error is just a special case of the standard deviation. All this formula is the same formula we were given during the sections on probability. Now, if we use these values, we can or our values from a standard error of a difference, we can calculate these values. So what is the standard error for a single proportion? Recall this is simply p times q over n. We take the square root of that whole thing. So square root of pq over n. Note now that we have ones here to note that this is the first value, the first individual, or the first group that we're interested in. Now the standard error for a different proportion is just going to be the exact same thing. pq over n. Take the square root. It's the same formula, but we want to know how we combine them. Remember, this is going to be exactly the same thing we saw on the previous slide. Standard deviation of d is the square root of standard deviation of x squared plus the standard deviation of y squared. So we plug those values in. So we're going to have our standard error of the difference between p hat 1 and p hat 2. And we solve by putting in our equations from up here. Take those squares out, and we get this standard error for the difference in two proportions. I do not expect you to be able to derive this formula at all, but I would like you to be able to use it if you're presented with it. However, we're going to be using StatCrunch for a lot of these calculations, and we'll see how in just a moment. This calculated standard error, however, assumes that both P1 and P2 meet the assumptions of normality, specifically that they are independent, and that there are at least 10 counts in each.